We are talking about linear programming, and we want to graph a system of linear inequalities and find the solutions of the system, and we want to solve linear programming problems. So here we're going to talk about testing vertices. So we have 4 constraints over here, and the first thing is we want to graph the constraints. So on our coordinate system, we want to graph these individual constraints. So we have x is greater than or equal to 0. So that is going to be this one right here. X is greater than or equal to 0. So for this line right here, we want to shade in that direction. We also have y is greater than or equal to 0. So that's going to be this line right here. We want to be to the right of the y-axis and above the x-axis. And then we have 2 more linear inequalities. So I want to put my grid on here because we'll have to have a grid in order to graph those. So one of them is x plus y is less than or equal to 6. So we can substitute the value in. If x is 0, then y has to be 6. So if x is 0, y has to be 6. And if y is 0, x has to be 6. So we can graph the line that goes through there. And in this case, then we can check. If we check 0, 0 to make sure that we're shading on the correct side, 0 plus 0 is less than or equal to 6. In that case, it is true. So if we check 0, 0, 0 plus 0 is less than or equal to 6, that is true. So we want to be on this side of the line. So we can see that we have this triangle for our feasible region, but we do have one more to check. And so we have x plus 2y is less than or equal to 8. X plus 2y is less than or equal to 8. And so we can subtract x. 2y is less than or equal to negative x plus 8. Divide by 2. And then we get y is less than or equal to negative 1/2 x plus 4. And then we can graph that one. So we start at 4, and then we have a slope of down 1 over 2, down 1 over 2, down 1 over 2, and we have that graph that goes through there. And then same thing, if we can check 0, 0, so that is that graph right there. If we check 0, 0, then we get 0 plus 2 times 0 is less than or equal to 8. So 0 is less than or equal to 8, and that is true. So that was our check. So we want to shade to the side of 0, 0. So we're above the y-axis, we're above the x-axis, and we're below our other 2 spots. So we have our feasible region is right there. So our first 2 steps are done. First step is graph the constraints. We did that. Second step, shade the feasible region. That's done. The third step is find the vertices. So we need to find the location of the vertices in here. We have 0, 0. We have 6, 0. We have 4, 2. And we have 0, 4. So we have those 4 vertices, and we need to substitute the coordinates of the vertices into the objective function. And so the objective function is written right here. And so we just have to take our vertices that we found down here and substitute them into that equation. So the first one that's pretty easy to do is 0, 0. So we can say P, and then we say 0, 0. So we're substituting in 0, 0. And that is going to be equal to 3 times 0 plus 0. And in that case, we get the function P evaluated at the coordinate 0, 0 is 0. So that was one of our vertices. Next one we can check is we can check 0, 4. So we take the function P and we can evaluate it at 0, 4. And so we get 3. So in this case, we're checking 0, 4. So the x value is 0. And the y value is 4. So 3 times 0, 0 plus is 4. So we get the function P evaluated at the coordinate 0, 4 is equal to 4. We have 2 more to check. We have 4, 2. So we can take the function P evaluated at 4, 2, and that is going to be equal to so 4 times 3 plus 2, and we get 12, 14. So the function P evaluated at 4, 2 is equal to 14. And then the last one we have is 6, 0. So the function P evaluated at 6, 0 and we get 18. 3 times 6 is 18 plus 0, so that is 18. So the last thing that we can look at after we substitute it in is we can select the max or the min. And if we look here, we have a max of 18. That's the largest. We have 18, 4, 14, and 0 is the min.